This is video 2.6.2, and the goal of this video is to be able to find horizontal and slant asymptotes and to end up graphing the rational functions. So in class, we already talked about how to find slant asymptotes and horizontal. So just a reminder, we're looking at the degree of the numerator denominator, and the slant asymptote occurs when the degree is one more in the numerator than the degree in the denominator. So of course that means like x to the third over x, or x to the fifth minus 2 over 2x to the fourth. It has to be 1 degree higher. So we're looking for when we have 1 degree higher. If I put x to the fifth over x to the third, remember that graph will shoot off to infinity, okay, because the denominator is so much smaller than the numerator for really large numbers. So let's take a look at some of these graphs and the steps we're going to take. So we're going to find our key points like our intercepts. We're going to find our asymptotes, vertical and horizontal or slant. And then we're going to plot some points beyond those key points that we already have to kind of see what's happening between. So taking a look at the first one, the y-intercepts are always going to be our easiest one because we're just going to simply plug in 0 for x. And we're going to get 0 to the fourth over 0 squared plus 1. That simplifies to 0 over 1, which is just 0. So we have a y-intercept that happens to be the same as an x-intercept. Okay? But of course, that's only potentially one of our x-intercepts. We want to make sure there aren't any more, because x-intercepts occur when the function is 0. But remember, the only way to make a fraction 0 is if the numerator is 0. So I don't really even care about the denominator. I'm more worried about the numerator. So yes, the only way to make this 0 is when x is 0. So this first point that I found when I plugged in 0 and I got 0, that's the only intercept for my graph. Now we take a look for some vertical and horizontal asymptotes. So when we're talking about vertical asymptotes, remember we're asking when is the bottom 0, because we cannot plug in that x value, otherwise it won't work. So my x squared plus 1, I'm asking when is that 0? Okay, so that's when the denominator is 0, because that's not valid. And I take a look, and it looks like the only time that's going to happen is when x is I. But of course, we're not worried about imaginary asymptotes, we're worried about real asymptotes. So there is no vertical asymptote for this graph. Now we're going to take at horizontal or slant asymptotes. Remember, we look at the degrees of the numerator and the denominator. The numerator is much larger than the denominator. So again, this means that it is not 1 more, so it will not have a slant asymptote. Since it's 2 more, it'll shoot off to infinity in either direction. So we have really nothing but 1 point right now. So we've checked for all the asymptotes. We know we're going to shoot off to infinity and or negative infinity, but now we need some more points. So we're going to plot some more points. For instance, we're going to plot some negatives and some positives. We're going to plot everything around this axis. We also would probably go right to our graphing calculator at this point and find some values beyond. But if we just plug in some points, 1 to the fourth, 1 squared plus 1, and it looks like we get 1 over 2, or 1/2. So when I plug in 1, I'm going to get 1/2. So we'll maybe scale this up by halves. This will be 1. Now what if I plug in negative 1? Notice that negative 1 will actually give me the same answer, because negative 1 to the fourth and negative 1 squared are the same value as if I plugged in 1. So I'm also going to get 1/2. So over at negative 1, I'm going to get 1/2 as well. So it kind of looks like this might be a V shape. But I want to plug in some more points to be sure. So maybe I plug in like 3, f of 3. 3 to the fourth, well that's quite large. 3 squared plus 1. The bottom quickly is 10. The top, 3 to the fourth, is 81. 81 over 10 is about 8.1. So I'm going to go over to 3 and up to 8.1. 2, 3, 4, 5. It looks like I can't even get that on my graph. So it looks like this is definitely shooting off to infinity, like we predicted. And think about why that's happening, because that numerator, that top number, gets it's really large when you take it to the fourth power. Again, negative 3, if I do the same idea as I did with negative 1, negative 3 will actually give me the same exact value. So this seems like it's going to be a U-shaped graph. I would use my graphing calculator to make sure, but it fits with the no asymptotes idea, and it also fits with the idea that the horizontal asymptote showed that it was going to go off to infinity. So my graph shooting off to infinity is probably my best bet. So I double check my calculator, make sure this looks right, and perhaps plot things like 2 and negative 2. But let's take a look at the next example. So again, we're going to do the same steps as we did before. So we're going to still look for the x-intercepts, we're still going to look for the y-intercepts, and we're still going to check for the asymptotes. So quickly, the y-intercept, plug in 0, 2 times 0, 0 minus 1. It looks like I get 0 over negative 1. So again, my y-intercept is at 0, 0. For x-intercepts, again, I want to see when is the numerator 0. So when is 2x 0? Because x-intercepts are when f of x is 0. So when is this function 0? And that's when the numerator is 0. Again, it looks like my only intercept is going to be at 0, 0. So now the question is, what happens around this? So in this case, we're going to check for vertical asymptotes. Vertical asymptotes are when the denominator is 0. So we're asking, when do we get an error in the bottom of the fraction that we're working with? And it looks like we're going to get an error when x is 1. So at 1, we're going to have an asymptote. And remember, we show that with a dotted line. So x can never approach 1. Okay, it can't equal 1, excuse me. It can approach it from left and right, but it can't ever equal it. So now let's take a look for some horizontal asymptotes. So in our case, our degrees are equal. They're both 1. They both have a 1 right here, even though we don't see it because there's one x on top and bottom. So remember, what we do is we look at the ratio between top and bottom. So we look at the leading coefficients. This has a coefficient of 2, and this has a coefficient of 1. So the horizontal asymptote is going to be at the ratio between them, 2 to 1. So it's going to be at 2. And that, of course, means that it's going to be a y value of 2. So this says that as y goes to infinity or negative infinity, the function is going to get increasingly closer to 2, but it will never equal 2. So we're going to draw a horizontal asymptote at 2. So we have this kind of graph. It's split into kind of 4 regions. So we got to figure out where the graph falls in those 4 regions. So a couple of key points to plug in would be points like something negative, maybe negative 3. Okay? Because we've already found the asymptotes, we want to know what happens by this red intercept, this point that we've already graphed at 0, 0. So if we plug in f of negative 3, we'll see what we get. F of negative 3, 2 times negative 3, negative 3 minus 1, negative 6 over negative 4. It looks like we get negative 1.2. So at negative 3, we get negative 1.5. Negative 1.5. Again, we're getting closer to 2. So it looks like my graph is going to do something like this. To be super positive that it goes down in this direction, I probably want to plug in f of 0.5 and just make sure that it goes down where I think it goes down. And it looks like I get 1 over negative 0.5. And that is actually negative 2. So, of course, it does. Actually, there's 1 point right there. So I sketched points around the intercept to see what the curve looks like. Okay? Now I've got to figure out where my other curve is. This is a function, so it will not have values. It will not have values that are, for instance, it will not have values that are going to be up here, because then it would no longer be a function. Okay, so I'm only going to worry about stuff to the right now. I've done the stuff on the left of the vertical asymptote. Now I'm going to do stuff on the right. So I'm going to plug in some points like 2, 3, and 4. I'm just going to see what happens in that section of the graph. So I'm plugging in 2, 3, and 4. Or again, you're looking at your graphing calculator to check some points. But plugging in 2, I'm going to get 2 times 2. I'm sorry, not 2, of course. I want to plug in 3, 4, and 5. I know 2 is my vertical asymptote. So I'm plugging in 3. See what happens at 3. minus 1, so let's say I get 6 over 2. So I get 3. So at 3, I'm up at 3. Plugging in 2, I see that I'm at 4 over 1, which is 4. So at 2, I'm up at 4. And last but not least, plugging in 4, 2 times 4, 4 minus 1. It looks like I'm at 8 over 3, which is about 2.6 repeating. So over at 4, I'm at 2.6 repeating. So it's a little bit lower than 3. So I'm starting to see the curve. And there's your graph. Okay? You've checked for points on the left, points on the right of the asymptote, and on the left and right of the intercept. And I have a nice curve. These are the checkpoints for the video for tonight. Hopefully you find the first one nice because it's already been factored, but make sure you work on finding those key points as well as the asymptotes. Don't forget to fill out the Google form as well when you finish the checkpoints. Good luck and bring in your questions tomorrow.